Hello dear students, so this is our first derivation of chapter ray optics. Okay, this is called mirror equation and this goes like 1 by v plus 1 by u is equal to 1 by f. This is what you might have used in your previous grades, and today we are going to derive this using basic geometrical concepts. So let's imagine a concave mirror, right, like this, who has its principal axis like this, and the pole has been designed marked as point P. Okay, we have taken an object AB, right, anywhere in front of this concave mirror, and this object has got its image here at A dash B dash. Two rays we have taken, one ray which is parallel to principal axis, and as we know, any ray which is parallel to principal axis passes through focus. So this is one ray. Another ray we have taken like this from B to this point pole, right, and it goes and cuts the original ray at B dash. So A dash B dash is the inverted image of this object. While we are not really bothered about the image formation here, what we are really concerned with is the relation between these object distance, image distance, and the focal length. So let's just mark these distances first. So this is my object. Okay, so from this object the distance of the mirror is u, right? This is the focal point, so this is f to p, this is small f, this focal length, and A dash B dash is the image. So image distance from the mirror is small v, right? So these distances are clear. Now let's go to the proof. Now the proof is basis similarity concept that you have learned in grade 10, right? So we'll take two triangles A dash B dash F, A dash B dash F, which is this. Okay, this is one triangle, and other triangle we are taking as MDF. MDF. What is this point D? I have just dropped the perpendicular from this point M to the principal axis. This point is D. So the other triangle is MDF. I am marking it here. It should be very clear to you now which triangle I am talking about, right? So now you can see these two triangles are similar because this angle is equal to this angle, right? Why? Because they are vertically opposite. This angle is 90 degree, this angle is 90 degree. So two angles being equal, these two triangles would be similar triangles. So for similar triangles, what we have, the corresponding sides are in the same ratio. That means A dash F upon FD this will be equal to A dash B dash upon MD. Clear? So simple proportionality rule for similar triangles. Now here we are going to take some approximation. We are talking about paraxial rays. Paraxial rays are the rays which are very, very close to principal axis. Now I cannot draw a ray which is very, very close to principal axis because otherwise this diagram will look very, very clumsy. So I have to make it a little far away, but we are doing this derivation for paraxial rays. What are paraxial rays? These are rays which are very, very close to principal axis. So you can imagine if you take a ray which is very, very close to principal axis, right? In this case, FD, distance FD would be almost similar to its distance FP, because point D will be very, very close to point P. So this distance I have ignored. Distance DP I have ignored. So my FD becomes equal to FP. Okay, that's written here. FD is equal to PF, and we know MD will be equal to AB because it's a rectangle, so opposite sides are equal. So if we do these two transformations, this equation will become A dash F upon FD. Instead of FD we are writing PF, so A dash F upon PF is equal to A dash B dash upon, instead of MD we are writing AB, right? So this equation takes this form. Now we are going to take another two triangles, right? Let me use a different color. Yes, okay. So we are taking two triangles A dash B dash P, A dash B dash and P. That means I'm talking about this triangle with yellow color I have shaded, A dash B dash P, and the other one ABP. ABP is this triangle I'm talking about. ABP. I hope you're able to focus on these two triangles. Now A dash, B dash, P and A, B, P are similar again. Why? These two angles are equal. Why these two angles are equal? Because one is angle of incidence, one is angle of refraction. So law of reflection gives us this, and other angle is 90 here, 90 here. Again these two triangles become similar. Now if these two triangles are similar, what we can say? A dash, B dash upon AB, A dash B dash upon AB will be equal to A dash P this side upon AP, A dash P upon AP, right? Now if you see this two equation 1 and 2, A dash B dash upon AB, A dash B dash upon AB, this is common. That means these two things will be equal. That means A dash F upon PF, A dash F upon PF will be equal to A dash P upon AP. So this is the relation we have got. A dash F upon PF is equal to A dash P upon AP. You can just follow through this, and it's very easy. We have used the similarity concept. Now what we are going to do is we are going to write all these distances A dash F and PF, A dash P and AP in terms of U, V and F. For example, you can imagine A dash F, you first focus on A dash F. A dash F, this means this distance, right? A dash F. Can I write this as V minus F, right? V minus F. Similarly, PF is what? P to F is nothing but your focal length, small f, right? Written here PF. What is A dash P? See this A dash P, this is the image distance itself, V. And what is AP? A to P is nothing but U. So I'm going to replace all these values in terms of U, V and F and with the sign. What is sign convention? Anything to the left hand side is taken negative. So I'll put these values with sign, right? So let's come here. A dash F, in terms of value it is V minus F, I showed you, and since it is towards the left hand side, it will be taken with a negative sign. Similarly, PF is a focal length, this is minus F, this C. PF is the focal length, and I'm taking this minus F because this is this is towards the left hand side. What about A dash P? A dash and P, this is nothing but V, but this will be taken as minus V again, and AP would be minus U. Now let's plug in these values in the equation we had derived. A dash F upon PF is equal to A dash P upon AP. So this will, A dash F would be, this will be minus V plus F, PF is minus F, and A dash P is minus V and minus U. This is simple math, guys, right? There's no physics here. When you do cross multiplication, you'll get this. So finally you will arrive at this equation, UV is equal to UF plus VF. Now you divide this equation by UVF together. You divide this equation by this UVF and you will get this derivation 1 upon F. Here you will be having 1 upon F. Here UF and UF will go, here 1 upon V, and this will be 1 upon U. So this is the famous mirror equation that you have been using so far. Okay. So next small derivation is an extension for this. This is a magnification derivation. Magnification, you have used this formula, M is equal to minus V by U. We are going to derive this as well. So we will start from one of the intermediate equation. A dash B dash upon AB is equal to A dash P upon AP. This is the formula we will start, or this is the equation we will start with. Now if you see A dash B dash is what? This is the height of the image. What is AB, guys? AB is the height of the object. So this is your magnification. Height of image upon height of object. What is A dash P? A dash P is V, and AP is U. So let's just plug in the values here. A dash P dash upon AB upon A dash P upon AP. So this means height of image upon height of object, V by U, which we call M. So if height of image is H, height of image is H dash, but we are taking minus because, very simple, this is below the y-axis, so this will be measured negative. So we'll put it as minus H dash. V is minus V with the sign. and u is minus u with the sign minus minus gets cancelled, this minus comes here, so m equals to minus v by u. What is m? This is the linear magnification. Linear magnification. Okay, so this derivation does not involve any integration or any complex mathematics, but it comes in the exams usually. So what I suggest that you guys practice this once now, and definitely this is something you have to revise and write once when you are closer to the examination date as well. Thank you very much.